Hello, peeps. Let us do a quick review of our PowerPoint of nuclear chemistry. Here we go. Watch the YouTube, it's cool. Radioactivity is easy as alpha, beta, gamma. Welcome to Greekland. Alpha man, beta boy, and gamma girl. Dun, dun, dun. So remember, alpha particles are helium nuclei. They have 2 protons and 2 neutrons. And they were used in Rutherford's experiment. And they are drawn this way. Sometimes you see the Greek letter, but usually not. You'll see this helium because it is a helium nucleus. So it's got 2 protons and 2 neutrons. So 2 protons on the bottom. 2 plus 2 is 4. So that's the mass. So it's helium. That's where helium comes from. We'll talk about that later. And it was used in Rutherford's Goldfoil experiment, the alpha particles. And here's the equation we have for helium. And here's one where we have radium, my bad. And radium radioactively decomposes into helium gas, which is an alpha particle, and radon, which we'll talk about also, is also a gas. And that's what happens in your house. And we'll talk about that later. So here's the equation. Notice the top numbers when you're doing the math. 222 equals 4 plus 218. The bottom number, 88, equals 2 plus 86. So we'll see how that works a little more later. Next type is the beta particle. What is a beta particle? A beta particle, here is a picture of it. It is an electron. Notice it has 0 mass, 0 protons, 0 neutrons, but it has a charge of -1. So how does that happen? Inside the nucleus, there's a neutron. It splits apart into a proton and an electron. The electron comes flying out, but it's not regular electron. It's a beta particle. It's radioactivity really fast. Comes flying out and leaves the nucleus. In the nucleus, the extra proton. So there's an extra proton in there. It changes the element. So now it becomes a different element with another extra proton. So watch out. We'll have trouble with the math on this one. So here it is. So notice 14 equals 14 plus 0. That's easy. 6 equals, 7 minus 1. That's not too bad. So all you really need to know is recognize little guys. Next, gamma rays. Looks like a little fishy or sometimes a Y squiggly down. The Hulk. And it's not a particle. It's actually electromagnetic radiation, so wave. And notice the atom doesn't change. So here we go. Notice it's 0, 0, no mass, no protons. It's just a wave. So when you see the equation, notice 240 goes to 240 plus 0. 94 goes to 94 plus 0. 0. It doesn't change the element. So it's really easy to spot a gamma radiation because the element doesn't change. So let's see. Transmutation, vocab word, to know that it's changing of one element into another. That's what the alchemists tried to do. And guess what? It is possible. They couldn't do it then. We can do it now. Lucky for us. But we can't make gold because it's real expensive and it's radioactive. So it's easier to find it than to make it this way. So we have alpha particles. Notice the alpha particle has the helium is the alpha particle. So when you see the equation with the helium, that is the alpha particle. The beta particle, and I'll move myself out of the way here. The beta particle is this electron. So you could see the E with the 0 and -1. That's the beta. And here is the gamma, which is the 0, 0. And the element doesn't change. So it's really easy to spot. As long as you can spot the difference, you're good. Okay. And it would help to do the math. So we're going to do the math in a minute. Okay. Where do we go? Next slide. Okay. Here we go. With all radiation, the mass is the same. The numbers are the same. This side equals that side. 222 equals 4 plus 218. The numbers on both sides are equal. It's a balance. a balanced equation. Isn't that amazing? Okay, now something new. We're talking about penetrating distances. What does that mean? That means how far the particles can go through something. So we have an alpha particle, which is a helium nucleus. And remember, Rutherford used gold foil. He used very thin foil intentionally because it could go through the foil. If he had a piece of paper handy, it would stop it. So your clothes can protect you from alpha particle radiation coming at you, which is good. Beta particles are a little nastier. They're a little stronger. Their electrons come flying through there. So they'll go through the paper. They'll zip right through the paper. But then it takes a little while, hits something, plastic or something, and it'll stop it. So you need a little more protection from the beta particles. And then comes the gamma rays, which are like X-rays and goes through paper, goes through plastic, goes through your bones, just like X-rays. But you need a big chunk of lead or a big chunk of concrete to protect you from these gamma rays. So in the order of penetration, meaning how far they can go, alpha particle, easy to stop. Beta particle, a little tougher, and a gamma goes right through there.